We're all ready for various kinds of apocalypses, like zombies, meteorites, gamma ray bursts, and so on. But are we ready for the strangest type of apocalypse possible? Here's the story of the strange apocalypse and the mystery of strange matter. Most of the matter that we interact with are made up of protons and neutrons, which are made up of even smaller particles called quarks. There are 6 types of quarks divided into 3 generations. Each generation is heavier than the previous. The first generation consists of up and down quarks. The second has charm and strange quarks. And finally, the third generation consists of top and bottom quarks. Our familiar neutrons and protons are made up of first generation quarks, that is, up and down only. Protons have 2 up quarks and 1 down quark, while neutrons have 2 down quarks and 1 up quark. These heavier generations of quark require extreme conditions of temperature and pressure to be formed. Most of them, however, quickly decay into lighter quarks soon after their formation, except the strange quark. Stars constantly undergo nuclear fusion that provides an outward pressure counteracting gravity. However, towards the end of their life, after running out of light elements to fuse, they can no longer sustain their fusion reaction, causing an inward collapse due to gravity. If the star is massive enough, they form black holes. If they are low-mass stars, they form white dwarfs. However, if a massive star is just on the verge of not being massive enough to form a black hole, they form a neutron star. Here, the pressure of gravity is so great that the electrons orbiting the nucleus fuse with the protons and form more neutrons. These neutrons themselves become so closely packed that they cannot possibly become denser without breaking Pauli's exclusion principle. It is theorized that it could be possible for these neutrons to then split into their constituent quarks, forming a quark star. Since the neutrons were made of 2 down quarks and 1 up quark, the quarks present in the quark star would be in the ratio of 2:1. However, if the pressure is still too great to achieve stability, half of the down quarks could theoretically convert into strange quarks. This would allow for a new type of matter consisting of 1:1:1 ratio of up, down, and strange quarks. This matter would be called strange matter. This strange matter is potentially the most stable matter present in the universe. It might even be that strange matter never naturally decays, and it is so stable that it would convert other matter into strange matter upon contact. However, if this is the method of formation of strange matter would exist and remain within these strange stars, and hence, they wouldn't pose a threat to humanity just yet. This strange matter might require the extreme pressures of a neutron star, quark star, or a strange star to form, but after their formation, they remain so stable that they could remain stable outside the star at normal temperatures and pressures as well. For this exotic form of matter to successfully convert normal matter to strange matter, a minimum threshold amount of it would be required to sustain the chain reaction. Any amount of strange matter that is enough to sustain this chain reaction would be called a strangelet. Any amount less than this would eventually decay back into first generation quarks. These strangelets could escape the prison of their strange stars during certain cataclysmic collisions between a strange star and a neutron star, or two strange stars. These strangelets could potentially travel through the cosmos for light years until finally coming in contact with regular matter. During their long travel, these strangelets are likely to decay into their ground state, which is predicted to be positive by most models. In case that they are positive, they will be repelled by the positive nuclei of regular matter and would not be able to start the chain reaction of converting everything into strange matter. But if by chance the strange matter is negative when it comes in contact with matter, it would readily get attracted to and interact with the nuclei of the atoms, converting the entire body into strange matter. This strange matter is far more dense and hence would shrink the object down apart from completely destroying it. Unlike most other forms of apocalypses, protecting yourselves against a strange apocalypse would be next to impossible with current technology, as strange matter changes the fundamental composition of elements themselves. Your underground, lead-lined nuclear bunkers with years' worth of food would stand futile in your attempt to save anyone or anything. Scientists speculate that if a negatively charged strangelet was to ever come in contact with planet Earth, the entire planet, along with everyone and everything on it, could potentially be destroyed long before we even realize what actually happened. Although the scenarios seem bad, most scientists are not worried about the strange apocalypse. Although potential strange stars might have been detected, none of them have been confirmed to actually be strange. It's not likely that negative strange matter formed in these strange stars would successfully reach all the way to Earth and cause an apocalypse. Although it is theoretically possible to form strange matter by accident as the byproduct of certain experiments on Earth, such as the LHC or the RHIC, none have been formed till date, and most scientists think of the idea as too far-fetched. Even if there was to be a strange apocalypse, it most likely won't happen anywhere near your lifetime. So don't worry and just relax. Thanks for watching this far into the video. Future episodes will have us go into more detail about how we detect strange stars and why they're fundamentally different. There's a lot more coming up, so while you subscribe, share, and comment, why not check out this other video that YouTube recommends for you? We're sure you'll love it. Either way, stay safe, stay curious, and keep learning.